Welcome everyone. Today we are going to focus on concepts of serial and parallel transmission. So let's jump right in. One of the most common operations that occur in digital system is data transmission. Now this transmission may occur over a small distance or long distance. If we consider transmission between computer and printer, so it is a small distance transmission. While if we consider data transmission between computers in different countries, so it will be a long distance transmission. So regardless of the distance, the information is always transmitted in binary form, which is language of the computer. So this data transmission, it can be a serial data transmission or parallel data transmission. So now let's try to understand what is serial and what is parallel. In serial transmission, the data is sent one bit at a time, that is bit by bit. Let's try to understand serial transmission with the help of example. Assume that we want to print high on printer. Okay, so let us assume that we have one computer here and there is one printer. And what is our job? What is our aim? We want to print this string high by using this printer. So obviously, in order to print this string high, this computer has to send binary code of this high to the printer. So how this transmission is going to occur? So let's try to understand. So as we are discussing example of serial transmission, so in serial transmission, try to understand that there will be only single wire. There will be only single transmission line which will be responsible to transmit all the bits. Okay, so as you can see in this particular diagram, so there is only one wire. Okay, and this wire is going to carry all the bits from computer to the printer. So let's assume that the binary code for each is 0100 1000, while binary code for I is 01101 So in order to represent this string high in binary form, here we are using how many bits? So 8 bits for H and 8 bits for I. So 8 plus 8, that is 16 bits. So this computer has to send these 16 bits to the printer. Okay, so is it possible to send all these 16 bits at a time? No. Why? Because we have only one wire, we have only single wire, and single wire can carry only one bit at a time. So now let's try to understand how these bits will be transferred. So LSB means least significant bit. The LSB of letter H is sent first. Okay, what is meaning of this? Let's try to understand. Very simple. Okay, so what is binary code of H? So binary code of H is like this: 0100 3 times 0. Okay, so here what we are saying, the LSB of letter H is sent first. So which is LSB and which is MSB? So the bit, okay, so this bit which is present on leftmost side, the bit which is present on leftmost side can be considered as MSB, that is most significant bit. And the bit which is present on this rightmost side, it can be considered as LSB, that is least significant bit. So in case of serial transmission, what is going to happen? Which bit will be transmitted first, whether MSB or LSB? The LSB least significant bit will be transmitted. So the serial transmission of this letter H will start from this LSB. Okay, so in other word, I can say that this binary code of H will be transmitted in reverse order. Reverse order means the transmission will start from this 0. So first of all, this 0 will be transmitted, then this next 0 will be transmitted, then this next 0 will be transmitted, then next one will be transmitted. Okay, so same is shown in this particular diagram also. So see how this letter H, how binary code of letter H is transmitted. So first of all, LSB is getting transmitted. Okay, so in case of H, which is LSB, so this 0. After 0, again we have two more zeros. So that's why you can see here bit sequence like this. Similarly, how a letter I will be transmitted? So again, transmission of letter I will start from its LSB. So which is LSB for letter I? So the LSB of letter I is 1. So transmission of this letter I will start from this LSB, and at the end the most significant bit of letter I will be sent, that is 0. Okay, so same is shown in this particular diagram also. So at the end this 0 will be transmitted. So this 0 is nothing but this most significant bit of letter I. So this is all about serial transmission. Now let's understand parallel transmission. What happens in parallel transmission? So parallel transmission sends multiple bits simultaneously. Okay, so in parallel transmission, many bits, multiple bits are sent simultaneously. Multiple bits are sent parallelly. So let's try to understand parallel transmission again with the help of an example. Okay, so let us consider again same example. We have computer here, we have printer here, and we want to print which string? We want to print high string. Right, so we have seen that this H, letter H, it can be represented by 8 bits. Okay, and this letter I, again it can be represented by 8-bit binary code. Okay, so in this particular diagram you can see that computer and printer, they are connected by many wires. So here we have 8 wires. 8 wires are present in between computer and printer. One wire can carry 1-bit data. So 8 wires can carry 8-bit data parallelly. 8 wires can carry 8-bit data simultaneously. So how this string high will be sent from this computer to the printer? So first of all, 8-bit binary code of letter H will be sent. Okay, so all 8 bits that are representing letter H will be sent on these 8 wires. Okay, so this is parallel transmission. And in second step, what is going to happen? 8 bits that are representing letter I will be sent, will be transmitted on these 8 wires parallelly. So this is parallel transmission. Now let's discuss comparison of serial and parallel transmission. In case of serial transmission, the data is sent serially. The data is sent bit by bit. Only one bit is sent at a time. But in case of parallel transmission, multiple bits are sent simultaneously. Multiple bits, many bits are sent parallelly. Serial transmission, it will take more time to transfer the entire message. Okay, as we are transferring data bit by bit. Okay, so in order to transfer entire message, entire data, obviously we will require more time in case of serial transmission. But in case of parallel transmission, we are transferring many bits, multiple bits. So that's why the message will be transmitted in less time. Okay, data transmission will occur in less time. Then serial transmission, often it is used for longer distance communication. Okay, and parallel transmission, it is used for short distance communication. Now if we consider example, the data transmission over USB, okay, the data transmission that take place in case of USB. So this is example of serial transmission. And if we consider data transmission that occurs over internal buses of the computer. So in the computer we know we have different bus like data bus, we can have address bus. Data bus is responsible to carry the data, address bus is responsible to carry the address. Okay, so this data bus, the transmission that occurs in data bus, the transmission that occurs in address bus, it can be considered as parallel transmission. Okay, so this data bus and address bus, they internally contain many wires. Okay, as there are many wires, so many bits can be transmitted at a time. Okay, so that's why this is example of parallel transmission. At the last, we can say that the choice between serial and parallel transmission will depend upon different factors like distance, speed, etc. Both methods, they plays important role in smooth functioning of digital system. I hope this overview provide you with clear understanding of serial and parallel transmission. Thank you for joining.